Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone, welcome to lecture 7, Organic Chemistry 3. Today we will continue on amino acids, peptides and proteins. Peptide synthesis requires the formation of amide bonds between the proper amino acids in the proper sequence. Simple acids and amines would form an amide bond simply by converting the acid to an activated derivative such as acyl halide or anhydride and then add amine to form the amide bond. Amino acid has both amino group and the carboxyl group. If we activate the carboxyl group, it reacts with its own amino group. So chemists had to develop many ways of synthesizing peptides. Solution phase method. To form a peptide bond selectively, the functional groups of the amino acids, amino and the carboxyl group, have to be protected. There are several amino protecting strategies available. The first one is using phenylmethoxy carbonyl group, abbreviated as carbobenzoxy or CBZ, introduced by the reaction of amino acid with phenyl methyl chloroformate, or what we call it benzyl chloroformate. Reacting benzochloroformate with amino acid under basic condition like pH 8 will lead to the formation of N-protected amino acid, N-phenylmethoxy carbonyl amino acid, which we abbreviated by CBZ amino acid. The amino function is deprotected by hydrogenolysis. Here is CBZ amino acid, hydrogen palladium on carbon will cleave in here to form the toluene and carbamic acid, which loses CO2 to give the amino acid back. The second method is to use 1,1-dimethyl ethoxy carbonyl, tertiary butoxy carbonyl, abbreviated as POC, introduced by the reaction of bis 1,1-dimethyl ethyl dicarbonate, or we can call it di-tertiary butyl dicarbonate. Upon reacting this reagent with amino acid in the presence of triethylamine, that will form the amide bond and provide us with POC, protected amino acid. In this case, the amino function is deprotected by treatment with acid under conditions mild enough to leave the peptide bond untouched. So we have POC amino acid, HCl or trifluoroacetic acid at room temperature will protonate this oxygen. Once that is formed, dissociate to give the cation, tertiary butyl cation, and carbamic acid, which loses CO2 to give amino acid, and the tertiary butyl cation will lose hydrogen to form the isobutene. The formation of tertiary butanol, if you have moisture in the medium, that might be just as a byproduct. Also, 9-fluorenyl methoxycarbonyl Fmoc was introduced to an amino acid via Fmoc chloroformate, 9-fluorenyl methoxycarbonyl chloride, but nowadays more commonly via Fmoc succinamidyl carbonate, NHS ester Fmoc NHS, which can be prepared from the acid with N-hydroxysuccinimide in the presence of carbodiimide coupling reagent to form the NH ester. For the HOBT ester, we can get that from the reaction of the acid with 1-hydroxy 1,2,3 benzotriazole, again in the presence of carbodiamide coupling reagent. Reacting the NH ester, active ester, with amino acid under basic condition sodium carbonate and 1,2-dimethoxyethane water as a media led to the formation of the carbamate, we call it Fmoc amino acid, and of course NHS as a product. In this case, the amino function deprotection is done by treatment with base, particularly secondary amines, such as piperidine. Results from activation of the ring proton beta to the urethane oxygen, alpha, beta. This hydrogen is acidic. Deprotonation with secondary amine led to the formation of stable anion with 14 pi electrons. This is actually the driving force, the formation of the anion, followed by elimination to form the carbamate, which loses carbon dioxide to form the amine back. For the double bond here, the amine will attack once again, nucleophilic attack this time. Once again, driving force is a formation of the carbanion, stable carbanion, and that end up with the formation of this compound. The carboxy-terminus of amino acid is protected by the formation of simple esters such as benzyl, methyl, ethyl ester. For carboxyl group activation and to form a peptide bond, treatment of the protected amino acid with ethyl chloroformate converts the carboxyl group to a mixed anhydride. Ethyl chloroformate with protected amino acid will transfer this group, carboxyl group, to mixed anhydride. That's anhydride part. Here is R, and here is R prime. Well, this is a very active carbon toward nucleophilic attack. Another method is to activate the carboxyl group using dicyclohexyl carbocarbamate, DCC. That acid with DCC will lead to the formation of O-acyl isourea, which upon protonation on this nitrogen makes this carbon highly active toward nucleophilic attack. So the amine will attack on this carbon, cleave this to form stable NN dicyclohexylurea, and of course formation of the amide bond. Consider the synthesis of alanyl vinyl phenylalanine of this structure. For solution phase peptide, synthesis begins with N-terminal and N at the C-terminus. So we are going to start with this part, alanine, protect with benzyl chloroformate to form the CBZ alanine. The protected amino acid then react with ethyl chloroformate to form the mixed anhydride and activate this carbon toward nucleophilic attack. Then react this protected and activated species with the second amino acid, valine. So the lone pair of the nitrogen will attack to form the coupled protected alanine valine dipeptide. So it is protected dipeptide at the N-terminal. This protected species then treated with ethyl chloroformate to activate the C-terminus of the dipeptide and form the mixed again anhydride. The activated mixed anhydride react with phenylalanine to form the protected tripeptide. So this lone pair will attack on this okay. The final step then is to remove the protecting group. Well, this group, as we mentioned before, can be cleaved using hydrogenolysis, using hydrogen palladium. We get in here toluene and the deprotected alanyl valyl phenylalanine target molecule. See you next lecture.